The topic for this session is game theoretic models of competition. Before I start, let me just briefly remind you that what I discuss here is available also in the book of Paul Belflamme and Martin Peitz, which you already know because I recommended this as a reading. And the topic I would like to discuss now can be found in sections 3.1 to 3.3 in this book. The first model I would like to discuss is the Cournot model. But before we come to that, let me briefly remind you why we are interested in models, or in strategic models of competition, in game theoretic models of competition. These are the models that are really interesting from the managerial point of view, because these are the models that take into account that the decision makers in the firms, that are the managers, that are hopefully you one day, that they will take into account when making decisions that will affect the performance of their firms. They will have to take into account how other managers of other firms make decisions. So you have this interdependency of decisions. You need to make the best decision with respect to what you know about your own firm, obviously, but also with respect to what other managers of other firms are doing, because in the marketplace you're competitors. So that is a difference to the models we looked at before, and that is why these models, the game theoretic models, are at the heart of what is important for managerial decision making. And most of what I will be discussing in this topic has also been a foundation for another discipline which is called strategic management, which you might find interesting, because these models have been used by people like Porter to develop a whole framework of strategic management. And most of it is based on game theoretic models. So I think from that point of view alone, it is very interesting for you to learn about these models. They will also help you to get at the heart of a competitive situation and hopefully enable you, once you're a manager, to better understand what strategic choices you have and how the game in the marketplace works out. I will start now with the Cournot model. The Cournot model has been the first model that was developed by a person called Cournot, a French economist. And at the heart of this model are a couple of firms that all have market power. What do I mean by market power? By market power, I mean that the decisions that are made by these firms will have an impact in the marketplace. That means what these firms do will be felt by other firms in the marketplace because it will also affect their profits. So if, for example, Pepsi-Cola decides to reduce the price for its product, Pepsi, that might have an impact for Coca-Cola, because it might be that Coca-Cola will sell less because they become relatively more expensive. So in the Cournot model, we look at exactly this kind of strategic interaction. The difference to the example I just gave is that in the Cournot model, the firms don't set prices, they set quantities. Later, I will talk, or in another section I will that you will be able to view, I will talk about Bergeron competition, that is where firms set prices, and then there will be another section where I talk about capacity constraints, which will explain the difference between these two models and how we can interpret them and how we should decide which of the models can be used in what situation, in what kind of real-life situation. Okay, let me start. Part 8.1, the Cournot model. As I said, in the Cournot model, there are a couple of firms, and these firms are competing against each other in the marketplace. We usually call such a situation an oligopoly situation. That means there are several firms with market powers and they interact in the marketplace. What they do determines demand, prices, and quantities sold in the marketplace. The Cournot model. As I said, it's a game theoretic model. That means it is a game with players who select strategies, and the selection of these strategies will decide what payoffs the players get. Just look back to the section on game theory and you will find that a game needs a couple of ingredients to be defined, to be well defined. The first is obviously the set of players. As I said, in the marketplace, the players are the firms. They are also the customers, we come to that later, but first of all, what is interesting for us here are the firms. are the managers of the firms who make the decisions. So think of the players as there being n firms. As you can see, I keep this as general as possible. I will develop this for any kind of firms, and then we will be able later to see, for example, what happens in the marketplace if the number of firms changes. But now we assume the number of firms is fixed, but it could be any number between 2 and n. Actually, you see on the slide it goes from 1, but clearly it only makes sense if there are at least 2 firms because we talk about competition. So what defines a firm? You already know this from one of the other modules on production. What defines a firm is its cost function, or at least that is one important ingredient of what defines a firm. Just to remind you, the cost function gives you the long run cost of production given the quantity that a firm wants to produce. So it is given by Ci of Yi. So it is this here. Okay, so for every firm there's a cost function given. That is all we need to know about the firm. What are the rules of the game? What are the strategies available to these firms? As I said, in the Cournot game, it's all about quantities. So the decisions made by the firms is how much quantity each firm would like to offer on the marketplace. So the games are, or the rules of the game are, the firms independently decide, each for itself, how much to produce. That's it. So it's a simple single number, the quantity. And this quantity here is given by this. Okay, so Yi is a quantity produced by firm I. So it is the strategy of firm I. So you might question whether that is a very strong simplification of what goes on in real life, and I do agree, but I would like to postpone the discussion of the realism of this model to later, once we've seen other models and can compare the two, and you will see that this model, obviously it is a model, so it simplifies real life, but is at the heart of the problem of a firm, as we will see later, who is capacity constrained. I can't explain this right now because we need a little bit more to do that. Think of this right now as firm set quantities, and later you will see meaningful examples where this game occurs in real life. So now, after all the firms simultaneously or independently have chosen their quantities, there is a total quantity produced in this market. This is denoted by Y. Y is defined in this formula. And as you can see, Y is just the sum of all the individual quantities. So assume there are 2 firms, one produces 20, the other 30, then Y would be 50, 20 plus 30. It's very simple. So we sum them up. These are the strategies of the firms. The rules, again, just to remind you, is all the firms independently, you can think of this, they do this at the same point in time. Independently means they make their own decision without knowing the decision of the other firms. Or in our notion of Nash equilibrium later, it means when they make a decision, they have to somehow anticipate what will be the decision or the decisions of the other firms. Okay, so that's a game. But now how do the other players in the market react to that? I mean, the other important players, as you know, are obviously the customers, the consumers. I mean, how do they react to what the firms are doing? In the Cournot game, the customers are not modeled as strategic players. So their decision is just assumed and not really founded by a game theoretic model. How do they make decisions? Essentially, the idea is that the price in the market is just set at a level where the total quantity produced is sold. And at the moment, I can't give you a better explanation for that in terms of why would the price be exactly at the level such that the total quantity is sold? I mean, you can think, if you want, about it like we did in the model of perfect competition. If the price was higher, then clearly the firm somehow would like to lower the price to clear the market, to sell all quantity. Because the price was higher than the price at which the total quantity is sold, then some quantity is left in the market, and the firms would not sell this quantity and probably might want to think about having a lower price. But this is not modeled explicitly in the Cournot game, the Cournot model. So you need to understand that firms are strategic players, the customers are not. And the price in the market is somehow given by the price at which the market clears. That means at which the customers as a total are willing to buy the total demand offered in the market, as given by the demand function. Okay, so that goes back to the section where we talked about how to derive a demand function for the customers and how customers make a decision. Okay, so the set of players is clear. Only the firms, the customers are non-strategic. The rules are clear. The firms set the quantities. And the price in the market, as I said, is the price at which the market clears. It means at which the customers are willing to pay are willing to buy the total quantity offered in the market. What now is a payoff for the players? Because obviously we need to have the objective function of the managers. How do they make decisions? They make decisions usually in a way that maximizes profits. That is a common assumption that we've always used, and we will use it here as well. So quantities are set in a way that a firm's profit is maximized. The profit of a firm as usual is revenue minus costs, so it's very simple. As you can see, it is given by this formula here. So what you see is that the profit is the quantity times the price, so that is the revenue, as usual, minus the costs. Okay, so here we are in a very standard framework, the formula, probably the kind of most common formula you will ever see during your studies. Okay, now we have all the ingredients necessary to think about optimal strategies, to think about the Nash equilibrium of this game, to think about what rational managers of the firms would make in terms of the optimal quantity decisions. We have the players, we have the rules, we have the payoff functions. We only need to figure out what the equilibrium is. The first, if you think about the game theory module, if you think about what we discussed there, the first thing that comes to mind is this game is somehow more complicated than most of the games, if not all of the games I discussed in that module. What is the reason for that? The reason is that a firm can virtually set any quantity at once. Think of an electricity company. I mean, what is a quantity? It's a certain amount of electricity in terms of, say, megawatts or watts, and that can be virtually any number. There are infinitely many choices a firm has to set its quantity. So the game is complicated by the fact that the strategy sets, the available strategies of each firm are infinite. How do we deal with this problem? I will show you on the next slide. The main idea is that we take the heart of what defines a Nash equilibrium, which is, just to remind you, that in a Nash equilibrium, every firm, in our case every manager of a firm, plays this strategy, that means sets a quantity which maximizes its profits, given that all the other firms also set quantities that respectively maximize their profits. So in a Nash equilibrium, somehow miraculously, all the firms set what we call the best responses. That means the quantities that set their own profits maximal, given that the other firms do exactly the same. And this will help us to identify the Nash equilibrium of this game, which, by the way, is called the Cournot equilibrium. Actually, Cournot lived long before Nash, and he had this model I would say more than 50 years, if I remember correctly, before Nash even thought about how strategic interaction works in games. And he, just for this very specific game, came up with an equilibrium which he called, obviously not he himself, but which was later called the Cournot equilibrium. And later people figured out this is a special case of the so-called Nash equilibrium. Okay, so this Nash equilibrium of the Cournot game therefore has a special name. It is called a Cournot equilibrium. Let's have a look at how this looks like.